Welcome, friends. I'm your host, Bill Murphy, civil engineer for Quick Supply Company, ASP Enterprises, Bowman Construction Supply, and Cascade Geosynthetics. Thank you for joining us for today's presentation. And good news, we're going to continue our Tech Talks webinar series throughout this summer. We had talked about possibly putting it on hold for the summer during the busy construction season, but we got a lot of feedback from our friends. Many of you are on this webinar, I'm sure, asking us to continue it. It's a free series. We get to share information from experts like today's speaker, and we're going to invite many more experts from across the country. So stay tuned for our schedule and keep us on your calendar. Our guest speaker, Mr. Tim Lancaster. Tim is the Vice President of Sales, Erosion Control Products, GrassWorx, LLC, St. Louis, Missouri. I've known Tim for a long time. Tim is the chairman of the ECTC, but before that, he went to college. He went to college at Purdue University, graduated with a degree in natural resource and environmental science. Tim's been in the erosion control industry for over 30 years. I knew him for several years when he worked for North American Green in various erosion technology, product development, and managerial roles until 2017. During his time with North American Green, he invented and further developed the company's line of VMAX composite turf reinforcement mats, of which we're very familiar with those. And from 2004 to 2014, Tim did serve as the chairman of the ECTC. I guess he's no longer the chairman. And since 2017 now, he's been inventing, developing, and launching a new line of simulated turf erosion control products with improved erosion protection capabilities. And as you see on the screen there, it's the evolution of turf reinforcement mat technology, hybrid turf Insta Armor mats. We also call them high flow erosion control products. And Tim is now an industry leader with his own company of GrassWorx, and he's the vice president of sales, and he is the manufacturer of these innovative solutions you're going to learn about today. But before I hand it over to my friend Tim, I want to make sure I do our company intro, and I usually do that before I do the bio. You folks know us. I see many of you have been on here a lot of times. If you're new to us, we actually have over 12,000 customers. I lament every time I do a webinar that I have not updated this slide. We have several CPESs on staff. We have over 30 salespeople and one civil engineer, and we keep him very busy. That's me. We are located across the Midwest, through the Rocky Mountains and into the Pacific Northwest, all the way up to Alaska with our friends at Cascade Geosynthetics. I'm lucky enough to be able to work with all of those folks, with all four of those companies. I will not expect Tim Lancaster to say ASP Enterprises, Quick Supply Company, Bowman Construction Supply, or Cascade Geosynthetics, all four of them. Tim, just call us whatever you want. You can just say ASP or whatever term you feel comfortable with.
Thanks, Bill.
Yeah, you bet. So, folks, you know that we're going to cover erosion control products today, and I often highlight stormwater solutions, but we are experts in geosynthetics across the board, hardscapes, and we have several other things that don't even fit in these categories, some innovative solutions, and a lot of the vegetated solutions. We're blessed with a lot of yard space and very big warehouses that we keep very tidy, very clean. You can tell that these are not mine at home. If you saw my garage, you wouldn't think I even worked for this company. I'm sad not to have our next slide in there, and that is a fleet of our trucks. We are not only experts at recommending products and having those available in inventory, but also delivering those to your job site. So if you have any questions after today's webinar, Tim will have his contact information in his last slide. And like I said, that'll be recorded, and we'll include it in the follow-up emails that we send out with a survey monkey. I would ask that you return that survey monkey to make sure we have all of your contact information correct for the PDH certificate. All that's free. And we also give you the opportunity, like I said, to ask any questions that weren't asked today. So with that, I want to hand the keys over to my friend Tim.
Good to go. All right. Well, thanks, Bill.
You're welcome.
And I want to thank you all for setting this up today. As Bill said, my name's Tim Lancaster. I'm with GrassWorx InstaTurf. We are a St. Louis-based manufacturer. I've been in the St. Louis area for about 35 years now, making AstroTurf-based products for a variety of industries. I came to the company about 2.5 years ago. I was previously with North American Green, was with North American Green for about 28 years. And I left there when we were bought by a competitor back in 2017. And when I left the company, I started thinking about ways to improve the existing erosion control technology that was out there at the time. And one of the issues that we sometimes experienced with our permanent turf reinforcement mat type products was that until those products became well vegetated, they just didn't provide a real high level of erosion protection. So I started thinking about ways to improve the immediate erosion protection that these permanent types of rolled erosion control products can provide. So at the time I had an idea in my head that if I had a product that looked like grass, then maybe it would perform and function like grass in terms of erosion protection as soon as it was installed. So I found this company called GrassWorx over in St. Louis, and I knew they made AstroTurf based products. I started talking to them about developing an AstroTurf based erosion control product. And that's what you will see here today in the new InstaTurf products. So before I get into the InstaTurf products, I want to talk a little bit in general about turf reinforcement mats. And as I mentioned, your conventional TRMs, HP TRMs, really have or provide fairly low erosion protection until they become well vegetated. So if you're using these types of products in a channel lining application and you're designing on permissible shear stress, these types of products and unvegetated give you a permissible shear stress typically between 2 and 4 pounds per square foot. Now, once they become vegetated, those numbers increase dramatically, usually 12, 14, sometimes even 16 pounds per square foot. But you got to get them vegetated. To get good mature vegetation establishment, it usually takes anywhere from 6 to 12 months, sometimes longer, depending on the climatic conditions and soils and so on and so forth. But it can take quite some time to get that good vegetation establishment. And during that time frame, it's just basically a time frame of an increased risk of failure of these types of products. Using rock and concrete, as soon as you dump the rock or pour the concrete, it sets up, they're at their maximum level of erosion protection. So one other thing that's kind of exacerbating the whole issue is climate change. And it seems like we're getting 100-year storm events coming about every 2 weeks now. And basically what that's doing is just increasing the odds that you're going to get a major storm event on your job site before these types of products become well vegetated. So that brings me to the InstaTurf products. And we refer to these products generically as hybrid turf instant armor mats. And they were developed as an effective soft armor alternative to rock riprap for your high flow applications. And they're really the only soft armor mat or mat type products out there today that give you immediate erosion protection that's equivalent to a very large diameter rock. They give you 3 to 4 times the unvegetated permissible shear stress of your conventional TRMs and HP TRMs. And I think of these products as kind of a hybrid vegetative armoring system. So you've got the simulated turf that protects, establishes, and then goes on to reinforce the natural vegetation that grows up through it. So the way the products are being used, you're basically putting seed down first, and then the natural vegetation grows up through the simulated turf. So there are 2 products in the lineup. One is called ShearForce10. It comes in roll form like your conventional TRMs. That's the product you see to the left there. And then the ShearForce12 comes in a panel form. It's a 3 foot by 4 foot panel, and it actually has a 1/2 inch rubber core incorporated into it for increased weight and ballast effect in more turbulent flow conditions. With the ShearForce10, it's basically a monolithic UV stabilized polyethylene structure. It's simulated turf. We call it monolithic because it's all molded into one piece. So there's no stitching or weaving there involved. And then on the bottom side of the turf is a very lightweight polyester fabric. And it took us quite some time to develop that fabric because it had to be open and somewhat loose enough to allow vegetation to emerge up through it. but at the same time provides some filtration characteristics to basically hold fine soil particles in place. As I mentioned, the product comes in roll form. Rolls are either 3 foot wide or 6 foot wide by 45 feet long. And the 3 foot wide rolls weigh about 50 pounds a piece, and then the 6 foot wide rolls weigh around 100 pounds. And the installation of the product, as I mentioned, you're putting seed down. Basically going to prep the soil first, put the seed down, and then install the product over the top. Usually with minimum 8-inch wire staples, sod staples. Sometimes longer fabric pins or even rebar stakes are used, depending on the type of soil you're anchoring into. And then the nice thing is, once the product vegetates, you can simply mow right over the top of it to maintain the vegetation. So you look at the product, some people look at the product and they think, oh, it's just artificial turf, and that's all it's ever going to be. That turf is actually quite functional in terms of erosion protection. So with the grass blades basically coming perpendicular to the water flow, or situated perpendicular to water flow, they're basically creating an elevated shear plane above the soil surface, which basically prevents a lot of the erosive force from acting upon the soil beneath the mat. The fabric on the bottom basically does two things. One, it acts as a filtration fabric to kind of keep the fine soil particles in place and keep those from being pulled out of the turf under high flow conditions. And then also the fine filaments within that fabric, especially if you have a cohesive soil, a clay-based soil, when they get wet, they basically stick to the soil and just kind of help lock things into place. So the testing that we've done on this product was done under the ASTM D6460 large-scale channel testing protocol. We did our testing on the product without vegetation. And if you're not familiar with this test protocol, they use a 2 foot wide, 40 foot long channel flume. They compact a sandy loam soil into the bed of the flume. And then typically when they're testing turf reinforcement mat type products, they're doing these tests on a 10% channel gradient. With our product, we started out on 10% gradient, experienced hardly any soil loss, certainly didn't come close to failing the product. So we actually jumped up to a 20% gradient to develop more velocity and shear stress in hopes of basically failing the product and coming up with a permissible shear rating for the product. We actually never did, as you'll see in a bit, but installation of the product in these test flumes done with 8-inch wire staples at a rate of 3.8 per square yard. And then they give you 3 separate test flumes to do these tests in. So there are 3 separate test plots. And within each one of those, they run 4 consecutive 30-minute flow events. So basically what they do is take baseline soil measurements or soil readings before they start your first flow event. Turn the water on for 30 minutes at a fairly low velocity and shear stress. Shut the water off, take soil loss measurements from the bed, and then turn the water flow on for another 30 minutes at a little higher velocity and shear. So they do that 4 times, and they're trying to reach a point where your product loses a 1/2 inch of soil, which is the failure point under this test protocol. They ran our product up to about 50 cubic feet per second of discharge, which was the maximum flow discharge that they had to work with. That generated velocity is between 24 and 25 feet per second, and shear stress is between 11 and 12 pounds per square foot. Through all these tests, our average soil loss was only 0.2 of an inch, which the failure point, as I mentioned, is a 1/2 inch. So the product never actually reached failure through this testing. So if we look at the results of the AS10 test in graph form as compared to some of the other products and materials that are out there, And here we're looking at soil loss versus applied shear stress. And the three graph lines you see to the left there, those are kind of your conventional TRMs and HP TRMs. The light blue line is actually a woven polypropylene high performance TRM. The light purple line there is a triple netted coconut fiber turf reinforcement mat, which I'm very familiar with. And then the orange line is a double netted polyfiber TRM. One thing you'll notice about all three of those products is from a performance standpoint, they're very similar. All three of those products are at or approaching that half-inch failure point between 2 and 3 pounds per square foot of applied shear stress. Another thing you'll notice is how quickly sharply those graph lines rise. And what that's telling you is those products are allowing a considerable amount of soil loss from one flow event to the next at fairly low applied shear stresses. Move to the right there, you'll see the yellow line, which is a tied concrete block mat. And then the green line is the ShearForce10 product. And you'll see the ShearForce10 product basically ran neck to neck with the tied concrete block mat up to the level of shear stress at which we tested the product. Now, we say this product basically gives you the performance of reinforced turf from day one. And this graph kind of shows you that. Here, once again, we're looking at soil loss versus applied shear stress. And the top three graph lines you see there, those are the same TRMs I just showed you, only here they are with 12 months of vegetation growth. So they're considered fully vegetated. The green line is the ShearForce10 product without vegetation. And you can see from a soil loss control standpoint, the ShearForce10 product actually outperformed these other three TRMs with full vegetation establishment. So comparing these numbers with rock riprap and these types of products, TRMs are often used or considered for use in place of hard armor materials like rock. And rock probably being the most popular hard armor material out there today. But comparing the numbers or shear stress ratings of these various materials versus rock, your conventional TRMs without vegetation, you see to the left there, typically between 2 and 4 pounds per square foot on a permissible shear rating. Once they become fully vegetated, that number increases to 12 pounds, usually as a minimum. Some manufacturers with different types of TRMs may publish 14 or even 16 pounds per square foot. The ShearForce10 product without vegetation basically starts you out at 12 pounds per square foot. And once it becomes fully vegetated, we're projecting a permissible shear of 16 pounds per square foot. So comparing that with some fairly large diameter rock, 24-inch, 30-inch rock, you'll see the ShearForce10 product basically is on par with a 30-inch rock riprap. And those are Federal Highway Administration recommendations for rock riprap. So one question I get often when I do these types of presentations in the past has been cost. So I put this chart together here that shows the installed cost per square foot. These are kind of nationwide averages, if you will, because it varies considerably from one state and one location within a state to the next. But looking at various soft armor materials, starting at the very bottom there, in yellow are your erosion control blankets. Those are your degradable straw, Excelsior, coconut fiber type materials. Those products installed usually somewhere in the range of 15 to 50 cents a square foot, depending on the type of ECB you're looking at, as well as labor rates, so on and so forth. And those products, depending on the type of ECB, can give you adequate erosion protection at shear stresses up to about 2 pounds per square foot. Once you get above that, that puts you into a permanent material, your TRMs or HP TRMs. And those products being based primarily on synthetic components, and they're more of an engineered type product. So there's more, say, QA/QC going into these products in the manufacturing process. Obviously, the products are more expensive. Those products anywhere from 70 cents to $2.25 per square foot installed. And they're good up to about 4 pounds per square foot, depending on the TRM. Once you get above that, that puts you into the ShearForce 10 territory. And you'll notice there, the ShearForce 10, 225 to 250 a square foot is at, or it's going to be typically a little bit above the cost of an HPTRM. But with the ShearForce 10 product, it gives you a lot more flexibility in terms of application, a lot wider range of applications the product can be used in, and a lot more confidence in the use of the product in your high flow channel applications. It also allows you to replace several different sizes or more sizes of rock riprap, up to a 30-inch rock riprap. And when you're using this product in place of rock, there's typically about a 50% or more cost savings, kind of depending on like I said, the location and where you're at, how far the job site is from the quarry, and transport costs, placement costs, rock, so on and so forth. So once you get above 12 pounds per square foot, kind of puts you into the hard armor concrete based materials, your tied concrete block mats, articulated concrete blocks. And with those products being concrete based, of course, they're more expensive. Prices typically ranging on the low end at $6 per square foot, all the way up to $14 and potentially even higher for your ACBs. So typical applications for the product, of course, your high flow channel lining applications, steep slopes where you may have additional discharge runoff coming from a drainage area above the slope, as well as your outfalls, downshoots, shoreline applications, I think is a great application for this product, be it a detention pond, or your little farm ponds, if you will, or small lakes, as well as small rivers and stream banks. Overwinter protection, say you got a job closing out in late fall and you know it's going to be the following spring before you get good vegetation establishment. This product's going to give you that very high level of erosion protection until it vegetates, as well as areas where vegetation establishment may be slow, or once it does establish, it's going to be quite sparse. That could be because of climatic conditions, maybe arid climates, or shady areas on a job site, or just wet or very poor soil conditions that are going to inhibit a good stand of vegetation from ever developing. So this is one of the, oops, back up here. This is one of the applications we did early on with the ShearForce 10 product. This was on a Peabody coal site, and they were looking at using the product in place of rock riprap on other areas of the site. So they wanted to do a little test section here. And this is a drainage channel that is kind of running the perimeter of an overburdened cap. It's like a 25-acre cap, and there's about 13 acres of that draining into the section of the channel where we installed the ShearForce 10 product. This went in September, early September of 2019. And you'll see they've got rock riprap check dams spaced about 75 feet apart along this drainage channel. So when we did the installation, we actually left a couple open areas downstream and upstream from the test section. Those were just seeded and straw mulched and kind of left as control sections, just to kind of see what would happen in those areas without mat protection. And then this picture was taken kind of looking downstream right after the mat was installed. You can kind of see some of the the washer top pinheads on the right side of your screen there in the picture that were used for installation as well. And then this picture was taken about a month after the installation, and during that time frame we had had hardly any rainfall. And I went out to the site, didn't expect to see a lot of vegetation growth, and I didn't. I mean, there were a few small seedlings kind of germinated and emerged up through the mat, but just not a lot of vegetation growth at that point due to a lack of moisture. So just 2 weeks after that picture was taken is when the rain started. And then October 21st, had over 1.5 inches of rain on the site. And then about a week later had over 2 inches of rain. I got back out there in November, kind of mid to late November. And since that time, through October and early November, they've had, I think, between 6.5 and 8 inches of rainfall. So the site saw a lot of rain there in the fall months, early fall, mid-fall. And when I went back out there, the first thing I saw was what you're looking at in the picture on the left side of your screen, is that several of these large gullies had formed in their overburden cap and had quite a bit of sediment plume there at the bottom of the gully. And then the picture you're looking at in the center of your screen is the test channel, the channel that we did the test section in, just upstream from our test section. And a little riprap check dam at that point has started to wash out. Some of the straw collected in the rocks there, and then a little bit of gully action in the channel itself, just down from that. And the picture to the right there was just below the rock riprap check dam, just downstream from our test section. You can see the gully starting to form there as well. So when I got to our test section, this is what it looked like. It's quite surprising. You know, it basically, you've got this green rectangular swath right in the middle of a lot of brown eroded soil. You can see all the rilling on the overburden cap, kind of the toe of the slope there, feeding down into the test channel, the test section, and then a lot of rilling around that. And then you can also see quite a bit of erosion just down in that control section just below where we installed the product. So picture to the left was taken day of installation, picture to the right on November 20th with quite a bit of good vegetation growth up through the mat. So when we did the installation, one thing we didn't do is use enough of the ShearForce10 product. And this was by accident, although it's made for some very cool photo opportunities, if you will. And when we installed the product, we thought we went wide enough on the channel. We thought we had the kind of the right side slope of the channel covered as well, based on the expected flow depth and wetted perimeter of the channel. But we didn't. And what happened was all this rainfall and runoff came and basically scoured out right next to our test section. And that shear face you see there on your screen, that is right where the edge of the mat is. That's right where the mat protection stops. And at this point, it's about probably on average 6 to 8 inches deep and 2 to 3 feet wide. And then the picture on the right side of your screen is a kind of a close-up of that ledge right there where the edge of the mat is and where it stops. And I don't know if you can see my cursor or not, but there's actually one of the staples we use for installation just dangling there from the bottom of the mat off that ledge. And just kind of a interesting, and it really kind of exemplified how well this product can work in terms of controlling erosion under some pretty significant runoff and channel flow. Just another look at it, looking upstream over that control section. And at this point, this was in December, just about a month after those pictures were taken. And that scour hole right down from our test section is probably 18 to 20 inches deep at that point. And then you can see all the scour on that side slope, right side slope coming down. So this was taken in May of 2020, spring of the following year. A picture on the left side there was taken early May, and late April they come in and filled that gully in, and I think kind of tracked over to compact it. And then by the end of May, we had enough rainfall during that month to basically wash out all that fill soil again. And then you can see the rocks that have collected in that gully, and those were washed in from that check dam upstream. So this is a little farther downstream looking upstream, and this is the riprap check dam right down from our test section. May 1st, you can see, quite a few of the rocks had washed out of it. And you can see the gully that's formed right below the check dam there. And then on May 28th, yeah, picture to the right there, basically at that point, the riprap check dam had just been leveled. It just pretty much flattened out. And that gully had gotten even larger there below the check dam. Now they had a grade control structure just downstream from that check dam. And you can see the size of rocks that were used here. I mean, the rocks probably were anywhere from 9 inches to 24 inches in diameter. And you can see a lot of these very large rocks had washed out of that grade control structure. So it just gives you an idea of just how much flow must have come through this channel on different occasions to cause this much damage to the riprap structures. So picture to the left, day of installation, picture to the right, end of May with nicely reinforced vegetation. Just a more recent update on this job. Got out there early March of this year, and it hadn't really greened up much yet. All the grasses were still dormant at the time. Say by now it's probably looking pretty green, but there was some green in the channel because they had some clover move in here, and the clover was still green, but all the grasses were still dormant and brown. And then the riprap check dam right down from it, you can see it's just pretty much blown out completely at this point. And then that gully, it's kind of hard to tell in these pictures, but the gully is probably about 5 feet deep at this point. So another application for the product, this was done on Peabody coal as well, stream bank stabilization. It was a situation where they had these constructed streams. They had to build like 170 miles of these streams to replace some of the drainage areas that they'd mined through. And so they built these streams, and this job, this stream in particular, they'd just finished it, and it was late October, and they knew it was going to be like the following spring before they got good vegetation growth there. So they were looking for something to lock the stream banks down with. So they used the ShearForce10 on the banks. Army Corps of Engineers would not allow them to use anything on the bottom of the stream, but they could put it on the banks, And then that winter we had in this area, I think maybe 5 inches of snowfall total. And the rest of the precipitation came in the form of rainfall, and very heavy rainfall at times. I think we probably had at least 6 2-inch storm events between late October and early March of that year. And every time you get a 2-inch storm event out there, that entire stream channel would just flood out like you see there in the center picture. I went back out there in early March and later in the spring, and what I found was the thing had vegetated very nicely. I was a little concerned because of all the rainfall. exactly what I was going to find, but when I got out there, and I think the picture to the right was taken at the end of April, and you can see some good vegetation growth on the stream banks. So channels, stream bends, areas where you've got higher velocity, higher shear stress. Product's great for those areas, even if you're using maybe a conventional TRM in a straight reach of the channel. Got higher shears and velocities on the bends, you could use the ShearForce10 product. Picture to the left you see there was a bend area on this stream that was where a coconut blanket was used. And the blanket had literally got stripped off the bank. A lot of the fiber had been stripped out of the blanket itself, and then the bank started to undercut. And then the other two pictures you see, picture in the center there was ShearForce10 on one of the bends. And then the picture to the right was that same bend about a year and a half later with good vegetation establishment and stability. This was another job we did with Dominion Energy out in Virginia. And this was an outfall area feeding into a drainage channel. And it's kind of interesting because this particular project, I think they had used another degradable erosion control blanket previously and a permanent TRM along with sod. And they kept having washouts and issues, erosion issues on the site. And they were about to come in and just dump rock in here. And our distributor in that area came in and talked to them about the ShearForce10 product. They thought they'd give a vegetative option, one more shot at it. So they installed the ShearForce10 in late July of last year. And I think after installation, within 2 weeks of installation, they had one of two of the hurricanes, which came up through the southeast last year, hit the site. I think it dumped like 4 inches of rain on site. Had a lot of flow in the outfall area in the drainage channel, but they didn't have any noticeable erosion. I mean, they were surprised at how well the product held up and kind of held everything into place. And then by the early to mid-September, they had some pretty good vegetation growth growing in that outfall area, which you see to the right. Shoreline armoring with the product, as mentioned earlier, detention, retention ponds, small streams and small rivers. It's probably not going to be used on a very large river, say like the Ohio River, except in maybe some protected areas. But stream banks, shorelines, those types of applications, the product is very well suited for. Picture to the right there, you can see that line of vegetation right there at the toe of the bank. That's right where the ShearForce10 mat stopped. So the mats basically held all the seed in place and soil in place and allowed the vegetation to develop and establish right at the very toe of the bank. The bioretention swales and pond areas. This picture to the left there, you can see here they used actually a combination of ShearForce12 and ShearForce10. And they used the ShearForce12 mats kind of in the bottom here and used the ShearForce10 rolls up on the sides of this bioretention area. Solar farms is another growing application for these products, growing industry for using these products. And we've been involved with, I think, 6 solar farms now, primarily out on the in the southeast and mid-Atlantic area. But they're using the product under their drip lines on the panels itself. They're putting installing material right below those drip lines to control erosion, as well as back under the panels because sometimes they have trouble getting vegetation growing under the panels themselves because of shading. And then also in their drainage channels. And some of these sites are huge. I mean, it's like some are, I believe, over 1,000 acres. So very large sites. a lot of drainage swells and outfall areas to contend with where they're using the ShearForce10. This is an oil containment berm, steep slope. This is out in eastern Pennsylvania. This berm itself, over time, originally they had come in and put a geoweb in here, geocellular confinement system. They'd installed that, and over time, water had gotten under it and eroded out the soil from under the geoweb. So they come in, strip that off. You can still see some of that in the picture to the left there, the left side of the picture there, far left side. So they come in, strip the geoweb off, prep the soil, seeded, and installed the ShearForce10 product in place of that. So installation is very important with these types of products, really your conventional TRMs as well as the instant armor mats. And it really boils down to two key points. One, you want to ensure and maintain that the product has contact with the underlying soil. And to do that means good soil preparation. Good soil prep is really key to getting these products installed properly. You want that soil as fairly smooth as possible, kind of like, and you really need that for good seed germination as well. But to get a good smooth soil surface to install the product, and you get that good soil contact with the bottom of the product, and fairly continuous. And then the use of proper anchors and staples, and also the proper number of staples and proper staple pattern in installing the anchors. So these are keys in making sure the product, one, has good soil contact to begin with, but also maintains that through and under flow conditions. And then keeping water flow on top of the mat. So you're going to want to trench the edges and secure your seams so the water flows on top of the mat and doesn't get under the mat and kind of breach those seam areas. And once that happens and erosion starts to occur underneath the mat, the product is not going to work like you want it to. So for installation guidelines, we publish installation guidelines for various types of applications on our website, and those are available in PDF format as well as DWG for use in CAD. So on installation, you're going to basically trench the, for a channel application, what we're showing here, trench the head of the channel, the product at the head of the channel, like you see them doing here on the picture to the left. And then when you're overlapping product with our product, we have incorporated into it what we call a seam lock edge or end. And basically what it is, in the diagram you see to the right there, one edge is fairly flat. And this is inset about 3 inches on the side of the product. And then that edge has fabric on the bottom of it, okay? Then the overlapping edge, the edge on the top, has a full turf but no fabric. So when you're running these rolls side by side to form this seam here, those are basically giving you that shingle effect. They're kind of a built-in shingle effect, and then you run your anchor through that seam area. So that's built in basically to provide for a seam that's nice and secure. It's not going to allow water to pass through, and but it will still allow vegetation to grow up through it. And it looks very natural, and you don't have a big bump or hump there, if you will, where the product's overlapped. So cutting the edge trenches in here, they come in and use a piece of equipment to cut the trenches in. And now they've backfilled those trenches and basically tracking over them to compact it. And then by the time installation is done, you should have something similar to what you see in the picture to the right there. So that brings me to the ShearForce 12 product, and really the only difference between the ShearForce 10 and 12 is with the 12 we incorporate this 1/2-inch rubber core, and that 1/2-inch rubber core has 1.5 inch holes in it to allow the vegetation growth up through it. Those come in panel form. They're 3 foot by 4 foot panels. They weigh about 30 pounds a piece, so they're easy for one person to handle and lay. And with this product, I don't know if you're familiar with some of the other scour or transition mats that are on the market today, but those other scour transition mats, they all require a separate underlay, be it an erosion control blanket, permanent turf reinforcement mat, or sometimes they'll put sod down first and then install the transition mat over the top. With the ShearForce 12, you don't need the separate underlay. So you're basically going to prep the soil, seed, and then install the ShearForce 12 panel over the top of that and let the seed and vegetation grow up through the panel. And installation of this product is typically done with like a 12-inch heavy gauge wire staple. Sometimes they'll use even heavier, like number 3 rebar, or even earth anchors in some cases if they're going into a fairly loose or muck type soil. And then just like the ShearForce 10, once this product vegetates, you can simply mow right over the top of it. So this product's going to give you a very high level of erosion protection as soon as you put it down, pretty similar to like a 36-inch diameter rock. So it makes it really ideal for these areas that are prone to scour, like your pipe and culvert outfalls and other areas where there's a lot of turbulence in the water flow. Testing on this product was done using the same ASTM D6460 protocol. And as you might imagine with this product, it did not fail in this test as well. With this product, our average soil loss was only 1/10 of an inch, so it did slightly better than the ShearForce 10 product, but certainly didn't come close to the 1/2-inch failure point. And then look at those test results in graph form. Looking at soil loss versus shear stress here. The purple graph line is a rubber scour transition mat with a separate poly fiber TRM underlay. So it's kind of that 2-layer system that I mentioned, where they install the TRM first and then install the transition mat over the TRM. And with that product, it basically reached that 1/2-inch failure point right at 8 pounds per square foot. The yellow line, once again, is a Tide concrete block mat, and then the green line is the ShearForce 12. And you can see the ShearForce 12 product actually did a little bit better than the Tide concrete block mat up to the level of shear stress that we had tested the product. Typical applications for the 12, culvert and pipe outfalls are probably the most common application for the product, but it's also good for use in areas where there's going to be considerable turbulence in the flow, or even some mild wave action, be it pond or shoreline or lake shorelines. Also, we're seeing the product used for downspout protection, something that we never really thought of, but some contractors and engineers thought it was a good idea. But they're using it for commercial building downspouts as well as residential. And sometimes they'll take one of these 3x4 panels and cut it into strips and use it like right there at the bottom of the downspout on a home. And what they do is seed first, and then once the grass grows up through it, they can just mow right over the mat. So your culvert and pipe outfalls, said most popular, most common. Picture to the left here was taken day of installation. Picture in the center was taken about 30 days later, and you can see the new grass growth up through the mat there. And then the picture to the right on the right was taken the following spring, and this was originally installed in the fall. Following spring, you can see the dominance of tall fescue taking over the area there where the mat's installed. Culvert cuts, berms, these are really good application for the product. I know in my area and over in the St. Louis area, they love to come in and just dump a pile of rock here, right there at the end of the concrete, a little concrete chute. And what often happens there is water finds its way around the rock, starts eroding around the rock, or they'll come in and spray all the vegetation around the rock. And there we go. Spray all the vegetation around the rock, spray some Roundup, what have you there, kill the vegetation back, and that basically just exacerbates and adds to their erosion problems. So these types of areas and applications, they could come in and use a panel or two of the ShearForce12 product, let it vegetate, and then just mow right over the top of it whenever they need to. Then the picture to the right is a berm along a parking lot. This is also in St. Louis, but this berm along a parking lot here, and they didn't have curb cuts. They're just allowing the water to sheet off the parking lot over this berm area into this bioretention area. So they use the ShearForce12 all along that berm. And quite frankly, they probably could have used just the ShearForce10 product here, and I think it would have worked just fine, but it was specified with a transition mat type product originally. So they use the ShearForce12. And just to wrap up the products here, they're really developed to help you handle the extra flow that we're seeing from, climate change and storms, heavier storms, more frequent storms associated with climate change. They give you a lot higher unvegetated permissible shear stress protection than your conventional TRMs and woven high performance TRMs. And they do so at a lower cost than using rock riprap and other concrete-based materials. And they also give you a look at vegetation as soon as you put it down. They kind of look like grass. And so it looks natural, looks green. And then if the vegetation ever dies back, you still have that look. And then also, and one thing I haven't mentioned so far is we use infrared reflective pigments in these products in the polyethylene. And that basically helps protect it from the product from UV light, but it also helps reduce heat load buildup within the product when it's exposed to direct sunlight, especially in the summertime. What we found with a lot of these polymer-based materials is, and you have this in concrete too, but polymer-based materials in the summertime, they're exposed to direct sunlight for any amount of time, really, they can heat up enough to burn new vegetation growth. So if you're doing a new planting in late spring or early summer, that can be an issue. Those products don't really seem to have that issue once the vegetation matures, and part of that's because they're shaded once the grass is growing over them. But new vegetation growth is susceptible to heat burn from these products. And honestly, they can get up to like 150 degrees Fahrenheit in direct sunlight. So we've rolled these infrared reflective pigments into the product to reduce that heat load buildup. And these pigments are also used in other building materials like decking and siding for homes to keep your deck from burning the bottoms of your feet in the summertime. From a design standpoint, installation, case studies, project case studies, all the information on these products are out on our website, as well as the ASTM test reports. We have design guidelines, permissible shear values for channel lining applications, as well as your slope and shoreline applications. And then all that's out on our website at insta-turf.com. And my email address and cell phone number are on your screen as well. So if you have any questions after the webinar today, if you think of anything, shoot me an email or just give me a call. Either way, I'll be glad to help you out. So
great job, Tim. So our contact information will be here at the end. And I just wanted everybody to know we have a whole lot of presentations scheduled. Don't worry about writing this down or taking a picture of it, because some of these may have to change depending on the availability of guest speakers. But I just want you to know that we've already been looking out to August. Now, we won't do them every week. Starting, I think next week, we're going to just start to go every other week. So I think we're going to take next Wednesday, the 14th off, and then try to do a 2-week rotation just for the sake of time, that a lot of people are busy. But I'll put Tim's information back up there when I go click on this question. Oops, I keep scrolling with my mouse. So Tim, the question is, are there any applications where they can use the ShearForce products where there are prescribed burns or controlled burns? And before you answer that, I do see the time is about the 1 hour. If anybody has to jump off because they have a conflict at 1 hour, just please look for your email for the Survey Monkey that'll come from our marketing department. And Madeline will include not only the Survey Monkey where you get to confirm your name, your company name, your position with the company, your email address. That'll get you your PDH certificate. We'll ask you if you have any specific products or projects you want to help with. We'll also ask if you had any questions that weren't asked today. So with that, Tim, what do you say to the controlled burn, prescribed burn projects?
Yeah, I would say that if you're using the product with vegetation and you want to use prescribed burning to maintain the vegetation, if the vegetation is just growing up through the product, I don't think it would work well, because I think it could probably get hot enough to actually melt the product. Now, I don't know for sure, but one thought I had was if you if you actually soil fill the mat and seed it, and having a mat below the roots, and the roots are going through the product, then the mat may not get hot enough to where it would affect it.
That's a good answer.
Right.
I think it'll be interesting to see if that plays out. So Leon, if you have a project like that, reach out to us and we'll go through your project and see if we can maybe recommend something like that on a small area. And Tim, I know it's 1:30 and I usually close these, but I do want to ask if for anybody that sticks around about permanent stabilization. In particular, we have a community in Colorado that's asking the contractors and developers to provide a permanent stabilization solution. And this seems like it'd be a good fit. How do you feel about that in the arid foothills?
I feel pretty good about it. The product's going to give you very good protection even without vegetation. And that protection is going to last for several years, even if they don't have vegetation established. But I'm assuming over time that they will have some vegetation growing with the mat, whether it be native type plants or what have you. And you really need that with any of these products over time, because they won't last forever in the sunlight. It's well UV stabilized and everything, but if they're exposed to sunlight for years and years and years without anything growing on it or protecting it, whether you get some soil or vegetated matter on top of it, what have you to shade it. But it would last for many years, without a whole lot of vegetation growth there. But long term, you want the vegetation growth there anyway, just for the root systems to kind of lock into the soil and hold everything in place below the mat.
Well, I like it. That's a good one. Thank you. And you talked early on about conventional TRMs typically have unvegetated permissible stress ratings that are a lot lower than people would expect. And what do we think those are? You have more experience in that than almost anybody I know. Unvegetated TRMs.
Anywhere from between 2 and 4 pounds per square foot. And most of the time, most products are around 3 pounds.
Wow. And you said ShearForce10 is around 12, didn't you?
Yes.
Wow.
So honestly, I was quite surprised at how well the product performed in the ASTM test, because in my former life with North American Grain, I was involved in most of their ASTM testing and performed a lot of that. And all the tests that I've been involved with, the products would, like clockwork, fail at that 3-pound mark or just under 3 pounds. So when I went to test the ShearForce product, at first I thought, man, if this thing can just push 5 pounds per square foot, that's better than anything out there today. And then when we started doing the test, I'm like, oh, we're going to go way past the 5-pound mark.
Yeah, that's excellent. And you
when
did.
We
And
got to 12 pounds and, ran out of flow and didn't fail the product. I was blown away.
well, that's right up there with, what is it, 30-inch rock riprap?
Yeah. Mm-hmm.
Wow, that's incredible. All right, Tim. Well, thank you very much. We did go a little long, which I never do, but I like to with Tim because he is an expert and we really value his opinion. So, Tim, thanks again. Everybody, thanks for tuning in. Please check us out. Keep an eye out for emails from us regarding follow-up to this. We really hope that from this, we'll schedule some Zoom meetings. I made a joke at the beginning about not being able to see or hear you folks, but that actually makes me sad. So I use humor to cover pain. We would love to have meetings with you directly, and it could be you and your entire office. It could be you and the contractor or city you work with, and we can do this virtually and leave an open mic where we could just have a dialogue. Tim's very good at that. You can fire questions at him. We could even pull up your plans and look at your specific project. So reach out to Tim, reach out to me, or reach out to anybody in our companies, and we look forward to hearing from you folks. Thanks again, Tim.
Thanks, Bill. Thanks, everyone.
Have a good day.
You too.